This is the Unit 4 test review. Number 1 says the table shows the number of vegetable plants planted in Sophia's garden. Express the ratio comparing the number of tomato plants to the total number of plants as a fraction in simplest form. So I can, when I write a ratio, I want to pay attention to the words, right? So I have tomatoes to total. I want to keep those in the same order. I'm going to keep the numbers in the same order as the words. So I can see from the chart that there are 10 tomato plants, but to find the total, I'm going to have to add these up. And total includes all, not just the other plants. So it includes the tomato plants, so I want to add that in as well. 5 plus 5 is 10, carry your 1, 1 plus 2 is 3, 4, and 5. So 50 total plants. So that's expressed as a fraction, but to simplify it, I need to see if it's divisible by anything. I can divide these both by 2. It gives me 5 over 25. I can divide these both by 5, or I could have divided both of those by 10. Either way, I'm going to end up with 1/5, okay, which can't be simplified any longer, so that's my answer. It only asks for fractions, but remember ratios can also be written with a colon, and they can also be written with the word 2. All right. Number 2, Lowe's sells paint for 5 gallons for $20. Home Depot sells 3 gallons for $12.60. Which store has the better buy? So anytime you're finding the better buy, you're finding the unit price. Price always goes on top. All right, so you're gonna write a ratio first with the price on top and then like the number of what you're buying on bottom. So for Lowe's, it's costing me $20 to buy 5 gallons. At Home Depot, it's costing me $12.60 to buy 3 gallons. If it's a unit price, it's the price for 1. So neither one of these are the price for 1. So to find the unit price, I divide. So again, top in, bottom out. It's just a division problem. 5 will go into 24 times. So that tells me it's $4 for 1 gallon at Lowe's. All right, so this is Lowe's and this is Home Depot over here. If I divide this one, top in, bottom out, it won't go into 1, it'll go into 12 4 times. When I subtract, I get 0. Bring up your decimal, don't lose it. 3 will go into 6 2 times. And I can bring down the 0, it'll go into 0 0 times. So Home Depot is going to be $4.20 for 1 gallon. So when I'm finding a better buy, right, I want the cheapest deal. So that tells me that Lowe's is going to have the best deal. Number 3, it took Connor 9 hours to drive 585 miles. At this rate, how many miles did he drive each hour? So each hour is the drive for 1, or the amount he drove for 1 hour. So that, again, that's a unit rate or an UNO rate. It's the rate for 1. So I'm going to do 585 miles. All right, this is miles per hour, miles over hours, for 9 hours. To make it a unit rate, I divide just like I did up here. So if I divide 9, it won't go into 5, it'll go into 58 6 times. 6 times 9 is 54. When I subtract, I get 4, bring down the 5, 9 will go into 45 5 times. All right, so that tells me he can go 65 miles in 1 hour. All right, or I could say 65 miles per hour like that. Number 4, Mike found that he tapped his foot 54 times in 27 minutes. At this rate, how many minutes does he tap his foot 210 times? What is the word ratio you should use to solve this problem? So at this rate is kind of a clue that you're going to be using a proportion to solve this. And so the rate they start with is times and minutes here. And then I'm trying to, you can see that the times is also used down here, and I'm solving for the number of minutes. So again, we're comparing 2 different things. That's a proportion. When I set up a proportion, I'm going to draw my 4 boxes, right? But before I do that, I need to make sure I get my words in the right order, right? So here, you can tell it's going to be times to minutes. So that's the word ratio they're talking about. What words are being compared? So it's not feet to times. It's not hands to feet. It's times to minute, okay? Not students to minute, times to minutes. All right, so if I know that those are the words I'm going to be using, it says in number 5, it's the same question. Mike found that he tapped his foot 54 times in 27 minutes. At this rate, and how many minutes does he tap his foot? 210 times, right? So I already know my words are going to be times over minutes. And then if I set up my boxes here and fill it in, I'm trying to find the set that matches that. All right, so 54 and 27, that's going to be 54 over 27. It's 210 times. All right, so that was on top. And then the one I don't know is on bottom. All right, so does this proportion match any of these? So 54 over 27, 210 over x, looks like it's going to be A, but just to check. 210 over 27, that's not right. 12 over 27, 210, that's not right. 54 over 27 looks right, except they switched the last one. So it is A. Oops, you can see that, but yeah. So what I was doing down here, right, was the words, and then I filled in the numbers, right, and then I figured out that this one matched what I had here. Okay, sorry about that. On number six, says Mike found that he tapped his foot 54 times in 27 minutes. At this rate, how many minutes does he tap his foot 210 times? Solve the problem. Okay, so they've just broken this down into 3 steps, all right? So we've already talked about this. It's times over minutes. We found the right proportion when we set it up on the other side. So we said it was 54 times in 27 minutes, right? This is up from here. At this rate, that's what told us it was a proportion. 210 times, that's on top, right? Because that's how many, it's times, not minutes. I'm solving for minutes. To solve a proportion, after you set it up, you multiply diagonally. So 210 times 27. So 0, 7, 14, and then I start my second row with a 0, 2 times 0, 2 times 1, and 2 times 2 is 4. Add those up, 0, 7, 6, and 5, right? But that's not my answer. I still need to divide by 54. All right, so over here, I'm going to divide now. Won't go into 5, it'll go into 56 one time. 6 minus 4 is 2, bring down your 7. Right, 54 doesn't go into 27. Right, so I have to put a 0 there before I can bring down a 0. Remember, keep everything lined up when you're dividing. So I'm trying to figure out how many times 54 goes into 270, and I might just have to guess. All right, so if I'm going to guess, let's try 5 times. 5 times 4 is 20, carry your 2. 5 times 5 is 25, plus 2 is 27. So that was a good guess. And then I have nothing left, and I have nothing to bring down, so that's telling me my answer is 105, and I was looking for minutes, so 105 minutes. All right, on 7, it says there are 232 dogs in the 8 kennels at Doggy Day Spa. This rate, how many dogs are in 5 kennels? All right, so this one, they just want you to solve the whole thing. They didn't break it into 3 parts like they did in the other one. But at this rate, kind of is your clue, right, that this can be solved with a proportion. So I'm going to start with my words. I've got dogs and kennels. I can just abbreviate, draw my boxes. I know that there are 232 for 8. And then when I keep reading, right, it's how many dogs are in 5 kennels. So that's going to be on bottom with my kennels. And then I'm solving for the dogs. So multiply diagonally, 232 times 5. 5 times 2 is 10, carry your 1. 5 times 3 is 15, plus 1 is 16. 5 times 2 is 10, plus 1 is 11. All right, that's still not my answer. I have to, again, divide. So baseball bat, baseball, if you remember that. And then keep things lined up. 8 won't go into 1, put an X there. 8 will go into 11 one time. 11 minus 8, that's 3. Bring down the 6. 8 will go into 36 4 times. That goes above the 6. 8 times 4 is 32. When I subtract, I get 4. Bring down the 0. 8 will go into 45 times. That goes above the 0. Right? And then I'm finished. Right? So my answer is 145. And what was I solving for? The number of dogs. Okay. Number 8 is telling me Larry practiced basketball 20 times in 5 weeks. His brother practiced basketball 12 times in 3 weeks. Are the rates at which each brother practice equivalent? All right, so I can see, right, these comparisons right here. I want to know if they're the same. So I'm looking at times over weeks. And Larry's was 20 over 5. And his brother was 12 over 3. So basically, I'm asking, is this a proportion, right? Are these equivalent? And I know there are different ways to do this, but the way that always works is by testing their cross products, okay? By multiplying, cross-multiplying. So 20 times 3, I want to know what that is. That's 0, and then 3 times 2 is 6. And then if I do 12 times 5, 5 times 2 is 10, carry your 1, 5 times 1 is 5, plus 1 is 6. So I can tell, since they have the same cross product, that yes, this would make a proportion, or the rates would be equivalent. Same thing. Equivalent rates are proportions. On number 9, it's telling me to evaluate 8 minus, and then I have in parentheses, negative 15 over 3. All right, so what do you do with this kind of problem? When the top is bigger than the bottom, all right, remember that just means divide, right? This is improper, right? But that's also another way to write division, right? I know that when I divide, I'm going to do top in, bottom out. 3 will go into 15 5 times. So I know this is 5. But what do I do with negatives? When I divide negatives, I'm using sleeping man, right? So this was a negative divided by a positive. which tells me my answer is negative. So this was negative 5. So now I have 8 minus negative 5. Right? And then to solve this, 8 minus negative 5, what I want to do is just rewrite it, right? This is keep, change, change. So 8 plus a positive 5. And then these are both the same. They're both positive. So if I add those together, I get 13. Right? So scattered throughout your test, right, you're going to have some review problems. This is one of them, just a review of the integers. Number 10 is what is 23% written as a fraction in simplest form? So 23%. So now I've moved kind of to the percent part of my test. There are only 2 types of percent problems. It's either a percent proportion or it's FDP. If they're asking me to rewrite something in a different form, that's FDP. All right, so I want to go from a percent, that's P, to a fraction. Well, in order to do that, I have to start at percent and move to decimal. So I'm starting with 23%. To move it to a decimal, I always go 2 places. And since I'm going percent to decimal, I'm going to the left 2 places. So now this is 0.23, right? To go from a decimal to a fraction, I say it, or write it like I say it. So the proper way to say this is not 0.23, it's to say 23 hundredths, which I would write as 23 over 100. Now, if you forget your place value, right, you can just look at the number of decimal places. There are 2 here, and there are 2 zeros, right? So that's kind of a way to check yourself. It's simplest form, so I want to see if this can be simplified. 23 is prime. I can't divide that into 100, so this is simplified. 23 over 100. All right, number 11 says a restaurant surveyed 350 people about their favorite dish. If 40% of the people chose macaroni and cheese, how many people chose macaroni and cheese? All right, so this is a percent problem, but they're not asking me to write it as a decimal or a fraction. So it must be the proportion. So I'm going to set up my boxes. I know in the percent proportion, one of those boxes is always 100. The percent always goes above the 100. I can see right here, right, that this number 40 is a percent. So 40 goes above the 100. The rest of my proportion is comparing the part to the whole. So now I have to decide what's the 350, the part or the whole. All right, so the 350 are all the people they asked, what's your favorite side dish? So that would be your whole. Not all of them are going to say macaroni and cheese, right? Only part of them. So that's what I'm solving for, the part. This is a proportion like the ones I just did. So to solve it, it's the same. I'm going to multiply the numbers diagonal from one another and then divide. So the 0 is just going to give me a row of zeros. Then I'm going to start with a 0. Or placeholder. 4 times 0 is 0, 4 times 5 is 20, carry your 2. 4 times 3 is 12, plus 2 is 14. I'm going to add these up. All right, and then that still needs to be divided by 100. So again, be super careful dividing. Won't divide into 1, won't divide into 14. Will divide into 140 once. I'm subtracting 100. That gives me 40, and I need to bring down the next 0. So 100 will go into 400 4 times. Then you may be tempted to stop, but if there's still a number to bring down, you got to keep going. And if you bring it down, you have to put a number on top of it. 100 won't go into 0, so put a 0 there, and now you can be finished. That's telling me that there are 140 people, right, chose macaroni and cheese of the 350 people they surveyed. Number 12, it says of those taking a driving test, 60% passed. 15 people passed their test. How many people attempted the test? So again, this is talking about percents, but it's not asking for a decimal or a fraction, so it must be a proportion. So I've got the 100. I know the percent always goes above the 100. Hardest part is the part and the whole, right? So this is what I got to figure out. So I know 15 people passed the test. I want to know how many people attempted the test. Well, which is, what are we talking about? All the people, right, had to attempt the test, but only some of the people passed the test. So the 15 is the sum of the people. That's your part. And then all of the people is what I'm looking for. How many people attempted? Attempted just means how many people tried, right? So then to solve it, I multiply diagonally. So 100 is going to go on top because it has more digits. That's what I like. On top, 5 times 0, 5 times 0, 5 times 1. Start with a 0 or a placeholder. 0 times 1, 0 times 1, and then 1 times 1 is 1. Add those up. Okay, and you're not quite done. You still have to divide by 60. So I'm going to do 60 into 1,500. Doesn't go into 1. Doesn't go into 15. So I'm dividing into 150. So again, you may just be guessing, right? If I can try it, 60 times 2, it's like 120. If I'm not sure, do 60 times 3. And that's 180, which is too much, so I'm going to go with the 2. Subtract 120, right? 0, 5 minus 2 is 3. I still have a 0 to bring down, so I want to do that. I'm trying to figure out how many 60s go into 300. So again, you may be guessing out to the side, you're just multiplying. Okay, I know it's 5, so 0 times 5 is 0, 5 times 6 is 30. So that's 5 times. All right, and then what was I solving for? I was solving for the number of people, right, who took the test. So that is 25. Okay. Number 13 says, what is 11% of 78? All right, so again, not asking my percent to be changed to a decimal or anything like that. So I'm going to set up my proportion. I know 100's on bottom. I know the percent goes above that. 11 goes above that. So where is the 78? So this one, maybe it's not as clear, the part and the whole. So remember, you can also look at the words is and of, right? So is sometimes is indicating the part, of is the whole, or out of, okay, it's talking about the whole amount. Right? So it doesn't work every time, but a lot of the times it's the clue you need. So of 78, 11% of 78, or out of 78, that's your whole. You're looking for the part. So doing diagonals, 78 times 11. So 8 and then 7, start with a 0 or placeholder. 8 times 1, 8 times 7, and then add these. So 8, 7 plus 8 is 15. 1 plus 7 is 8. 858. So I have to divide it by 100. Right? Can't divide into 8 into 85. It'll go into 858 8 times, which is 800. When I subtract, I get 58. Now, because I have a remainder, I have to add my decimal, which I need to bring up before I add the 0 to bring down. Right? So 100 will go into 580. Above the 0 I just brought down, I'm going to put the number 5, right? So I'm subtracting 500. Which gives me 80. If there's still a remainder, then I still have to keep going. So I'm going to bring down another 0. 100 will go into 800 8 times. So that goes above the 0 I just brought down. And once I have nothing, right, left to bring down and nothing left over, I'm done. So 8.58 is the number, or is the part, right, that I was solving for. And this time it's just a number. On 14, it says order the numbers from least to greatest. All right, so I've got a percent, a decimal, and a fraction. Before I can put these in order, they need to all be the same thing. So either all percents or all decimals, all fractions, but I have to get a common denominator, so I'm not probably going to do that. So this is FDP, right? I want them all to be the same thing. So I like percents, but I like decimals too. So I could do negative 345%, or I could change it to a decimal, and it's negative 3.45. Okay, I'll show you both ways. 3.09, that's already a decimal. If I move it over 2 places, it's now a percent. So 309%. Okay, I do that. The fractions both need to be changed, and they start with a negative 3. So I'm going to put the negative 3 here. And then I'm going to do top in, bottom out. So top goes in, bottom goes out. 5 doesn't go into 1. Add your decimal, bring it up, add a 0. 5 will go into 10 2 times. And then I'm going to subtract. So I had a negative 3. Now it's negative 3.2. I am fine with that as a decimal. Add a 0 to keep everything lined up. Or move it 2 places to make it a percent. Negative 320%. Now be careful on these because some are negative and some are positive. So don't drop the negative. Same thing with the 3 9/10. I'm going to write down my whole number so I don't forget about it. And then I'm going to divide my fraction. So top in is 9, bottom out. 10 won't go into 9. Add your decimal, bring it up. Add your 0, 10 will go into 90, 9 times. I subtract, I get 0. So 0.9. So I have 3 was in front of the 9/10, so 3.9 is fine for a decimal. I can add the 0 to keep it lined up. Or I can move it 2 places and make it 390%. All right, so done. Oops. Again, you want to make sure that your negatives, you have I have 2 that are negative, right? And I have 2 that are positive, right? So I have everything with the right sign. All right, so least to greatest, pay attention to that, least to greatest. If I have both negatives and positives, I'm going to start with my negatives. So my smallest negative is actually the one that looks the biggest, right? It's the furthest from 0. So the negative 345% is going to come first. Or the negative 3.45 if I'm doing decimals. Then the negative 320%. Or the negative 3.2. And I'm going to switch over to positives, right? So it's just regular, 309%. And then 390%. Okay, and then this is fine, except that if they don't give it to you all as percents or all as decimals, you have to know how they started. So that negative 345% started as a percent. So we didn't change it. It was the same. The the negative 320 was this other negative right here. So that negative 3 1/5. 309% was really the decimal, 3.09. And then the last one, 390, started off as 3 9/10. So just make sure you know how everything started, okay? Because you may have to drag things in order. And then the last question says, an archer practiced shooting arrows at a target for 4 weeks. The table shows the archer's success rates in hitting the bullseye. In which week did the archer have the highest success rate? So I'm not being asked to find the percent of something. I'm asked to compare things. So when you're comparing things, that's an FDP problem. So I need everything to be the same thing so I can figure out which one is the highest. 14 out of 25, it's really not a fraction, decimal, or percent, but 14 out of 25, that kind of sounds like the fraction 14 over 25. So I can start it by making it a fraction and then changing it, right? So top in, bottom out, 14 is going to go in, 25 goes out. I can't divide 25 into 1 or 14, so I'm going to add my decimal, bring it up, add my 0. So think about quarters. How many quarters go into $1.40? Well, 5 quarters make $1.25. That's pretty close. When I subtract, I'm going to have to borrow. 10 minus 5 is 5. 3 minus 2 is 1. If there's a remainder, I'm going to add a 0 and keep going. 25 into 150. Think about how many quarters. So 6 quarters to make $1.50. So this is 0.56. All right, so if I want decimals, that's fine. I can make this 0.56. If I want percents, I'm going to move it 2 places, right? 0.56. Move it, right? It becomes 56%. So you decide, do you like percents? Do you like decimals? So this is, if I want to make it a decimal, right? I move it 2 places the other way. This is 0.75, or I can leave it 75% if I'm comparing decimals. 0.8 or 0.8, right, goes here. I can add a 0 to keep it lined up, or I can move it 2 places and make it a percent, 80%. And the last one is a fraction, so again, I need to do top in, bottom out. 20 won't go into 1, won't go into 11, so I'm going to add my decimal and my 0. 20 will go into 110 5 times. 5 times 20 is 100. When I subtract, I get 10. I'm going to bring down another 0. 20 will go into 100 5 times again. Okay, so that gives me the decimal 0.55. If I want to make that a percent, right, move it this way, so 55%. All right, so now they're all the same, and I'm looking for the highest. So the highest number, right, they're all positive. It's going to be 80.80 or 80%, which came from week 3. So my answer would be C. All right, so that's a review for chapter 4. You're looking at proportions and percents mainly. FDP is part of the percent, and ratios are part of the proportions, but they're all related. So make sure you study, and I will see you in class.